Hello, my name is Metin Arıdaşır. This is for the seventh part of explanation of my theory. Remember, COMPTON experiment have some results, two peaks. Always we see two peaks, except here. What is the reason for changing the distance between two peaks? Now I'm going to emphasize distances here. Now, in the context of this view, this is largest distance from this peak point to that peak point. Okay, here at 90 degrees, from this point to that point, a distance. Notice that, please, distance. But now there is no distance, zero. Okay? These are so important. Today I will notice and I will put forth some formulas about that, according to my theory and my formulas. Because of that, COMPTON experiment is so important experiment, but its COMPTON experiment doesn't prove the photon is a particle, and yes, we know, etc. But this is that explanation of COMPTON experiment is wrong, according to my theory and my formulas. My former videos, I have explained, but now, again, I put forth another viewpoint to explain the COMPTON experiment. Yes, I hope you see. This is the first sketch that I have drawn. What is the reason for changing the distance between two peaks? Obviously, these distances represent the ways to go. Therefore, here there must be time intervals. But how do peaks occur in a certain time interval with respect to angle? If a single wave pulse intertwined with successive waves of that at rest blue circle is single wave pulse. These two black circles are successive waves from free electron motion from. But now we think of that free electron motion form is at rest. Okay. If a single wave pulse intertwined with successive waves of that at rest free electron motion form, relative velocity of single wave pulse is equal to 0 because of single wave pulses velocity is always in all direction, enlarging velocity is speed of light. But successive waves of free electron motion forms velocities may change respect to direction of relocating electron motion forms, velocity, direction, etc. Remember. But now we think electron motion form is at rest and single wave pulse from proton bounded electron motion form and successive waves from at rest free electron motion form. These two kinds of light intertwined. Okay, here. Now we know, according to my theory and my formulas again, if an electron motion form at rest, it doesn't need to accelerating for propagating and producing successive waves. It goes on produce and propagate successive waves, but now in all direction in same velocity at c. Okay. Because of this and because of as a characteristic ray single wave pulse wavelength smaller than that intertwined with successive waves, 2 of that c is equal and respect to successive waves velocity is 0. Single wave pulse velocity. Again, if a single wave pulse intertwined with successive waves of that at rest free electron motion form, relative velocity of single wave pulse is equal to 0 respect to free electron motion forms successive waves velocity. So the result in all direction, the distance between the peaks behind of crystal after filtering is always still the same and will be constant at 0 point here, will not change. 0.0022 nanometer. In the direction of 90 degree, 0.0022 nanometer. In the direction of 135 degree, same, unchanged, 0.0022 nanometer. Here, same, 0.0022 nanometer. In the direction of 45 degree, okay. If free electron motion form is at rest and there is no continuous spectrum now, okay? Here, when free electron motion form is relocating at a certain velocity here, like this, okay? Crystals here, crystal here, crystal, okay? Then in this direction, say, normal direction, 0.0022 nanometer, but here, 0.000, I'm sorry. Yes. Larger, because of larger, 0 point, yes. 0.00375, larger. And here, 0.000644, smaller than this, in this direction, 45 degree. And at a certain rate, what is determinative for this changing? Not smashing with electron and photon. Not striking because of not striking between photon and electron. this is not the case according to my theory and my formulas, because of there are two different kind of waves or light intertwined and interact, okay? And free electron motion forms relocating velocity and direction, mainly direction, because of free electron motion form. If free electron motion form relocates, there will be different wave velocities respect to angles, and this changing variability transferred here to characteristic X-rays, peak shifting, not striking. Reason is not striking of the photon and the electron. Reason is locating free electron motion forms, changing wavelengths, respect to angles and its velocity. Okay. I have told you before, these peaks are approximately filtered by Bragg crystal from two different kinds of intertwined light. One of relocating free electron motion forms successive waves that are represented by a continuous spectrum, and the other one is proton-bounded electron motion forms single wave pulse that represented by characteristic X-ray. B. Each of the waves enlarged together. Here, each of the waves enlarged together. Single wave pulse enlarged at c velocity, and successive waves, this is different velocity now for successive wave. Here, c plus, say, in the direction of 180 degrees, c plus velocity of electron motion forms, this is greatest velocity of wave. Here, c minus velocity of electron motion form. Remember from my former videos, d equal to c minus ve electron motion forms velocity cosine alpha, and wavelengths were changing, remember from my former videos, lambda alpha equal to lambda n minus delta lambda cosine alpha, etc. Each of the waves enlarged together relatively at their certain velocities. Here enlarging single wave pulse, and here enlarging black circles, successive waves. Okay, at certain velocities. Each of the waves enlarged together relatively at their certain velocities. This is important. Mainly, free electron motion forms successive waves involve single wave pulse. Because their wavelength is greater than single wave pulse, because successive waves wavelength greater than single wave pulse representative wavelength, this is the reason. Therefore, in most cases, successive waves arrive at the crystal first. Okay, here, second. Therefore, in most cases, successive waves arrive at the crystal first, as transferring the single wave pulse that mixed as shifted at certain rates. Here, bigger, shifted peak. Okay. Then in a certain time, snapshot. This is important. Yes. Basically, yes. Step by step, I will going to tell you. Then in a certain time, again, therefore, in most cases, successive waves arrive at the crystal first. Here, blue single wave pulse enlarging. Here, black successive waves. Okay, enlarging together. Relatively different velocities, or sometimes coincide same. Okay. Therefore, in most cases, successive waves arrive at the crystal first as transferring the single wave pulse that mixed as shifted at certain rates. Then, in a certain time interval, single wave pulse arrives at the crystal directly. Here. Always this one single wave pulse, this one single wave pulse peak, single wave pulse peak. Here, shifted single wave pulse, shifted peak, shifted peak, shifted peak. But now, in the direction of 0 degree, only single wave pulses, not shift. Okay. There is no distance between different peak distance. Okay. In a certain time, single wave pulse arrives at the crystal directly. Eventually, these two peaks occur on the graphs. Yes, it is important. So, the single wave pulse will have a relative velocity with respect to free electron motion forms successive waves velocity. Okay. Relative velocity of single wave pulse equal to, notice please, C minus D. C, single wave pulses speed. D is free electron motion forms successive waves velocity. Okay, but D alpha we say. Now, and then it is equal to C minus, again C minus electron motion form velocity cosine alpha. Then cancel, plus. This is the formula that I put forth. Relative velocity of single wave pulse respect to successive waves of free electron motion forms is equal to electron motion forms cosine, velocity cosine alpha. This is formula, don't forget that. Okay. Because of, remember, d is equal to c minus delta lambda, not delta, c minus electron cosine alpha. Alpha is not here. Don't forget this. Relative velocity respect to single wave pulse. This will be determinative for this distance changing. Because of electron motion forms velocity motion and its wavelength angles are determinative for Compton experiments results shifting. Because of shifting of the peaks that result of Compton experiment, the reason is relocation, motion of free electron motion form, and its successive waves variability. These are determinative for these shifting distances between two peaks and this shifting, second peaks shifting, okay? It is so important. I hope you look at, after the video, you focus on these sketches that I draw. Now, here. Complex, same but complex. Here. For another snapshot, okay. Here. I hope you see. This is 90 degrees, 135 degrees, 45 degrees, 0 degree, in the direction of free electron motion form, relocating direction, okay, 0 degree. This is $216,340.909 kilometer per second, okay, electron motion form velocity, and lambda n equal to 0.22 nanometer, okay, here. This is normal peak distance, we can say here, NPD. This is formula for normal peak distance is equal, alpha is equal to NPD minus NPD cosine alpha, okay. Yes, in this direction, lambda n and delta lambda plus here, because of greater than 90 degree and greater distance. All of these changing are parallel. Lambda n minus delta lambda cosine alpha for successive waves variability, okay, here I wrote, and this distance variability in same rules, in same reasons, okay, here, this formula relationship is important that I put forth. Okay? Shortly, I want to say, in this direction, relative velocity of single wave pulse respect to successive waves of free electron motion form is equal to 0. Here, unchanged. Normal peak distance unchanged because of this. And here, the velocity of free electron motion from successive waves equal to c, unchanged. There is no delta lambda is equal to su, no change is equal to 0, or delta lambda chi, no change in this direction. But here, for 35 degree, for example, lambda alpha changed here, and relative velocity of single wave pulse changed here, and this rate, and this distance, I said here, normal peak distance shifting, changing here at the rate of this rate, okay, this rate. It is important. Shrinks at same rate, enlarge at same rate, here enlarged distance and enlarged successive waves wavelength at same rate, okay, here determinative. And mainly, I emphasize relative velocity of single wave pulse is maximum here, and excess this successive waves velocity, and here result is point, no shifting, only this, okay. From my former videos, this is another point of view of my theory and my formulas. This is mine, another point of view. You compare these sketches. I advise you to compare these sketches, okay? I hope you see. Then, here from my former videos, another snapshot. Okay, I hope you see. Here. You know this one.